Hello all, this is John Lee with OUP. I'm a principal leader on the tech side and I largely manage a lot of our software investments here. Thank you for jumping in and tuning in to our webinar today titled Launching an Open Source Startup at a University. This conversation is largely going to be around open source as a go-to-market strategy for university startups. There are a lot of advantages of open source software as a go-to-market over proprietary software models, and we'll discuss how open source software has really become the dominant way to commercialize software in this industry. The speakers for this webinar will be myself and David Dorsey. David, could you introduce yourself?
Sure, I'm David Dorsey. I'm a senior associate on the tech investment team here at OUP. And I've been here 3 years, and prior to this, I was an engineer with Lockheed Martin.
So this webinar will be structured a little bit differently from our past webinars if you've attended some of our past webinars. So over the years, we've received lots of inquiries about open source software startups from commercialization offices. We decided to create this presentation and host this talk as a webinar, largely to address questions on how exactly you do go to market with open source software and how you commercialize it. We like to receive questions from our listeners, so if you'd like to submit a question during our webinar, including right now, please go ahead and use the Q&A feature on your toolbar, which is likely either the top or the bottom of your screen, depending on your computer. In a moment, you'll see a poll appearing on your screen. If you could fill this out, we'd love to know how many people are attending this webinar today. So with that, we'll get started. So we believe that university startups are a great fit to adopt open source as a go-to-market strategy. Not only has it become one of the dominant go-to-market strategies for enterprise startups in recent years, but it's also extremely well aligned with the values of academia, primarily in allowing for open, collaborative, and peer-reviewed research. Therefore, we actually think it's a pretty winning combination for open source and open source startups from university researchers. So in this presentation, we'll largely discuss how researchers, grad students, and entrepreneurs can leverage open source software and the advantages it lends when launching a startup. So what is commercial open source software? A commercial open source software startup is a company that relies heavily on or builds upon, extends an open source software project as a fundamental building block justifying its existence. There are lots of different configurations in which startups can be built upon open source software. Below are two pretty different examples of companies commercializing open source software at their core. And so on the left, you have Databricks, which is commercializing Apache Spark. Apache Spark is a distributed general purpose cluster computing platform that was developed at the AMP lab at Berkeley. The problem they identified they'd solve for users is Apache Spark remains open source and anybody can use it and download it and run it. But the real challenge is installing and deploying Apache Spark and using it on a scaled basis. It's really hard to do it. It's really hard to get a lot of performance advantages when doing it yourself without hiring lots of experts to do it. And so Databricks largely deploys Apache Spark or their version of Apache Spark on the cloud, and they charge Apache Spark as a service. They'll charge for the consumption by basically compute time, and they're basically adding a margin on top of the AWS compute costs for users. So this is really a very service-oriented model that they've developed. On the right side, Red Hat is taking a very different business model where they are providing professional quality assurance for Linux, and then also subscription customer support for Linux and other open source projects that they support. They really build no proprietary features or functions on top of Linux, and they are strong contributors to Linux, but have not created any specific IP around any of it, and largely open source most of the code base. And so both of these represent very different models of open source go-to-market. We'll get into much more later on this presentation, but I just wanted to start by giving two examples of very popular open source companies that are going two very different routes. So one might ask why open source or open adoption is advantageous to proprietary software. One of the main things is the speed that open source provides for enterprises. Open source code that enterprises are taking in can be modified and iterated on top of. And that wouldn't be possible with a traditional software vendor. They would really have to get permission to do any modification or have to pay an NRE fee to a proprietary software company to make those changes. And therefore, the ability to iterate on the fly really makes it really valuable for a lot of enterprises using open source software because it allows them to skip reinventing the wheel every single time they're building out a software product. An additional thing that open source software is it tends to be pretty scale native. Open source software projects are usually founded to directly deal with a problem or a technology problem that's been readily identified. And then these solutions are externally validated by contributors. And oftentimes these projects are tackling the hairiest and the most relevant problems for technology companies. And so this is really proven out for web scale native projects where open source projects have tackled everything from serverless architecture to distributed computing to scalable search solutions, really some of the most relevant problems in the industry that proprietary software startups are oftentimes a little bit behind or too slow to recognize some of the changes that are going on in the broader ecosystem. Interoperability is another reason why open source software is quite valuable. Interoperability comes pretty naturally for open source projects where contributors are often building plugins and connectors for popular projects, and they're enabling these systems to exchange information openly, allowing data to flow through regardless of the infrastructure or technology. This unlocks substantial value for its users because of the interoperable nature of these projects, it provides substantial advantage over the monolithic proprietary software stacks. And the last big advantage of open source software that we've really seen even within our own portfolio is the independence of open source software. One of the greatest risks for any company developing proprietary software from a vendor is the risk of being cut off of essential software in the event of an acquisition or a company going under. So open source software usually allows companies to avoid the risk of incorporating outside or third-party code into their own products. Oftentimes in our portfolio, earlier on, we see these companies making trade-offs between whether they buy proprietary software and avoid reinventing the wheel, or they build from scratch and spending time and money to build these things. Open source software is really a good medium and a good trade-off between both of those things, where you can have third-party software, but be able to keep it in the event that a vendor shuts down.
Okay, good. Before we start the next slide, actually, John, there was a question from someone on the Q&A line here, asking if they're not familiar with the web scale native, as a definition. Could you maybe give a definition of what you mean by web scale native?
Yeah, web scale native is a pretty general definition of the scale needed to reach billions of users. So essentially, going back even a decade, the internet was much smaller, and because of the web, and since the IT infrastructures have had to become much more scalable, enabling serving millions, billions of users, and also trading and analyzing lots of data. And so it's just a general term to mean kind of immense and incredible scale.
All right, thank you. The slide we have up here is a list of open source software companies, spin-outs, that are generating $100 million or more of recurring revenue annually, right? This is based on a spreadsheet that you can actually check out yourself. It is created and it's maintained by Joseph Jacks from the OSS Fund. And if you go to oss.cash, C-A-S-H, you can see the whole spreadsheet. What this spreadsheet shows is that the estimated revenue and value of these companies, as well as the core OS projects that they're leveraging in their products. So, for example, Cloudera is based on or is commercializing some version of Hadoop. They have their own proprietary version of Hadoop. And you know, some of the questions we have when we're thinking about open source software companies is, you know, how do investors view these companies? Like, have they done well in terms of exits? We're all familiar with the success of Red Hat as an exit. You know, the question is whether there will be another Red Hat. And, you know, there is consensus that open source software creates a lot of value. And the question is, how much of the value are these companies actually capturing? So, you know, the caveat here is that as a rule, like, open source projects are always going to be able to create more value than any one individual is going to capture, as opposed to 100% proprietary software, which is meant to capture 100% of the value. But if you go to the full list, if you go on the link there, there's actually another field that talks about how many exits there have been and for what amounts. And so there are 41 companies on this list of $100 million run rate or more. And there's a total of $68 billion of exit value from these 41 companies. And, you know, of course, half of that, $34 billion, came from one acquisition of Red Hat by IBM. But the remaining $34 billion, of that remaining $34 billion, $22.5 billion was realized in just the last year. So MuleSoft was acquired by Salesforce for $6.5 billion in March of last year. Pivotal went public for $4 billion in April. Magento was bought by Adobe for $1.7 billion in May. Elastic IPO'd for $2.5 billion in October, and then GitHub was acquired by Microsoft in October for $7.5 billion. So, you know, these are this suggests that there has been an uptick certainly in exits, and certainly there are companies that are creating a lot of value here. And another thing to notice here is that we have this on a slide. One of the columns says monetization, which is sort of their path to monetization. And we'll talk more about these different kinds in later slides. But I just want to note for now that most of these are what we call, and what we'll define later as an open core as a business model. And we'll talk more about that later. You know, one other thing to point out here is that a few of these are actually university startups. The ones that are highlighted in bold, Databricks, Nicira, and SourceFire, are actually all university spinouts in some sense. You know, Databricks in particular was founded by a team of professors and graduate students from Berkeley. All right, let's go to the next slide. Yeah, so another perspective we can get of overall adoption of open source projects is not just by looking at their revenue, but also by looking at the size of the developer communities that are involved in the project and the number of commercial projects that have spawned from that open source project. So this graph here, this list here, is an index that was created by Battery Ventures, and it's a list of about 40 companies, and we're showing the top 10 right now. So, you know, to produce this list, they're measuring Google searches, job postings that request expertise with some particular OS software, the number of Stack Overflow questions, the number of GitHub repositories, etc. So, you know, here it's no surprise that Linux is number one, and it has spawned Red Hat and also the Ubuntu as companies. And then Git, which came in at number 2 here, has also inspired 2 companies, GitHub and GitLab. So it's worth pointing out that most of if not all of these companies shown here are building on kind of broad platform projects. They're addressing a layer in the IT stack, particularly for storage, database storage, and analytics for businesses that are addressing a layer in the IT stack where there's already conditioning to allocate budget. Something else you notice here is the amount of funding that is raised by these companies to commercialize these projects. And I think it's probably true that many of these companies raised more money than they needed to get to scale. You know, open source, one of the nice things about it is it's meant to be, it should be very efficient. It shouldn't cost this much money to get to scale, but this also might be a sign of the investor excitement about the space. We can go to the next slide.
Great. And so over the last decade, there's been a systematic transformation of the enterprise IT stack towards open source startups. And so you really see open source startups leveraging every piece of this stack, everything from cybersecurity to applications, data management, storage, networking, and infrastructure software. In each of these categories, there are actually quite a decent number of startups that where the projects originated from universities, for example, Databricks and data management, or Nicira, and Mesos in infrastructure software, and SourceFire in cybersecurity. So this slide illustrates some of the differences in go-to-market between a traditional enterprise software startup and an open source startup. So in a traditional enterprise software startup, the company is started usually with some identification of the problem that they want to solve. Then a product is built, and the first time that the product is largely interacting with customers is in this broad phase called product market fit. This is where a company either gets traction or they don't, at which point they raise lots of money and will go on to scale if they're successful. Open source startups are a little bit different in that usually open source software projects are created to address a specific technology pain point that is not necessarily related to a business pain point or is not a business yet. And so these software projects are started, they're often contributed to, sometimes they're successful, they'll receive lots of contributions and integrations, until finally some of these reach a critical mass of usage that the project owners start to consider whether there's a startup to be built out of this or not. And so I think there's a question around how do you identify an open source startup and what are the parts that you really want to commercialize. This is actually, identifying the problem amongst users is actually the point at which you're deciding what the actual product of an open source startup will be. The project and the technology itself is open source, so you can't necessarily directly commercialize that, but there are ways. But what you're largely doing in identifying the problem amongst users is you're identifying a core challenge amongst all users, whether it's the difficulty in installing or deploying the software, or the need for support contracts like Red Hat does, or sometimes even just building a proprietary product on top of the open source software. But at this point, you're identifying the problem just like a traditional enterprise software startup, and you launch your company after that. Another difference in open source software startups after launch is that there's a substantial amount of leverage of the open source software community that these companies will do. Oftentimes, there are lots of initiatives to continue to contribute to the code base of the open source software code. Sometimes companies will sponsor host foundations to bring contributors and users together, which are very helpful in generating leads for the commercial entity that is commercializing the open source software. And then oftentimes, these companies are taking leadership of the direction of the open source software project. And then, so on the next slide, we thought it would be very helpful and illustrative to walk through a case study of a university startup that is commercializing open source software. Full transparency, this is a portfolio company of ours. It was initially a project called Bro, which is now called Zeek, which was founded by Vern Paxson at Lawrence Berkeley National Labs. This was an open source network analysis framework to solve network forensics on a hyperscale network. This was for Lawrence Berkeley's climate network, which was far broader than enterprise networks at that time. And so this was quite a while ago. This is 1994. And so that open source software was solving a specific technology pain point. And how do you do network forensics on these super scaled out networks? Quite a few years later, in 2011, there started to be a lot more interest in Bro and Zeek at that time. And Zeek decided to host its first conference, or it was called BroCon, where 55 people attended, and a community started emerging and coalescing around the new developments around the software. In 2012, there's quite a lot of uptick in endpoints installed with Zeek, and there were lots of commercial and academic customers that were starting to get interested in Bro as a commercial product. In 2013, the company Corelight was formed. It was formerly called Broala. And the problem that they started to identify was that people had a lot of trouble in deploying Bro or Zeek across their enterprise. And so in 2014, the company created a product where they packaged Zeek into an appliance for ease of installation at enterprises. Fast forward to 2017, the company raised $9 million Series A from Excel and OUP to build out next generation cloud native products. This was the value-added products and services that they started to build out for the customers. And then in 2018, they raised another $25 million from General Catalyst. In 2018, they also had substantial community support at ZeekCon. There were over 260 attendees. Everybody from Amazon to Facebook to Google were in attendance, and the community continues to grow, and Corelight is very much a substantial contributor to that community.
All right, thanks. So, to kind of move on a little bit to talk about how open source companies' sales process is a little bit different than the traditional sales process. And this kind of goes back to one of the previous slides that talks about the difference, the fundamental difference between open source companies and traditional companies in how they do customer discovery, how they define which vertical they're going to go after. So for traditional enterprise software process, you either you produce leads either through marketing or through direct sales outreach to the customers. And by this time, you already have you've identified, in a sense, who your customers are. So at this point, you have product market fit, and now you're trying to get meetings with them so that you can sell them your product. Now, that can be an expensive project because you have to do cold calls and marketing, and you have to kind of get distribution. One of the nice things about, potentially, if you have a large enough community, is if you have an open source software project that has a large community of developers and users, you already have some warm leads waiting that you can already start to reach out to. So one of the things that's nice about open source software projects and the commercialization process is that, and I'll take a step back here because I'm thinking a lot about university spinouts. So when we first encounter university spinouts, very often they are kind of horizontal platforms. They have not identified a business vertical, and they're still identifying what their product is. And so, as we were talking earlier, it's helpful to see what bug requests and feature requests people are making in the open source project to get a sense of how people are using it and what might be potential use cases and also potential customers. And so this also helps to generate warm leads. The last thing that's really nice about this is when you're getting your first few customers as a startup through the traditional model, you have to convince enterprises or customers that they can trust you and that you won't go away in a year and that you won't mess up their product timelines or anything like that. So the nice thing here is you can show that you have a large community of developers that are involved in this project. It's active, it's not going to go away, and it helps, really helps to kind of make those initial reach outs and initial phone calls, and you don't have to do so much time on demoing and proof of concept and pilots because there's already a large user base online. And they can see some of the use cases from the open source project, even if there isn't revenue. Let's go to the next slide. And then let me also say this. So, open source startups are still startups. So as an investor, when we're looking at a startup, we're still looking for the same things we would look for in a traditional startup. So, as I said before, very often when we encounter university spinouts that are working on open source projects, they want to go after a broad platform. They want to have as much impact as possible. And we're always trying to get them to kind of define their product and to pick a vertical to go after. So once they've done that, we still have to have some evidence that this is a rock star team. Like they have leadership quality, they have a good strategic sense on how to go to market, they have a good go-to-market strategy. They have to show that this is a value-added project. It's nice if when they go to enterprises that there's budget allocated for the services that they're providing. There has to be a big enough market. We're still doing market sizing here. You want to see momentum that's required to attract independent developers and users of the OSS. The nice thing about this is that they can demonstrate with some evidence how their momentum. They don't have to wait, and so they should have some demonstration of the market, of the community, whether or not it's a value add. But still, at the end of the day, OUP in particular, we're investing in team first, and so the team is still really important, whether it's an open source commercialization or not.
So a common question asked to us is, how do we really identify which open source projects are taking off or not? And I would say that there's no real perfect metric for this, but there are a few ways to track progress of an open source project. And so one of them, and I would say probably one of the more popular ones, though I think it's not that accurate, is GitHub stars. And so oftentimes there's a metric on a GitHub page where contributors or users will star the item. If there's a lot of traction on that, it means that there's probably some popularity around a project. It doesn't necessarily mean anything much more than that, though. There's some additional analysis that you can do on a GitHub page, like the Google Analytics for a specific page, or the amount of pulls for contributions on that page. Although I would say it's just a piece of the puzzle. Some of the other things that we analyze are Gitter, which is the messaging board for forums for projects on GitHub. This is extremely helpful in understanding where the questions are coming from in terms of the users and contributors of the project. This is just to get a better understanding of how people are using the project and what issues they have. Google Trends is helpful to analyze larger projects that have gotten a substantial amount of scale and to understand them in relation to some of their popular competitors, or just to be able to track their progress. And then Telegram is an example of a newer messaging forum where lots of people, especially around blockchain, are following projects via Telegram, and Telegram is used as a platform to directly reach users. I would say that this is probably more relevant for blockchain-related projects, but has been extremely helpful, at least in our analysis of tracking open source projects. And then Stack Overflow, it has probably the most content. This is simply where developers can ask questions specifically about an open source project, and they can be answered in great detail. So moving to the next slide, this is just an example of Google Trends between Kubernetes and Mesos. And what's relevant here is for anybody that's trying to analyze where they should be placing their bets. It was helpful in 2015 to really understand that Kubernetes, which is in the greenish color, overtook Mesos in that time period and really scaled beyond that. And so this is just to indicate that there are ways that are pretty meaningful to track from these open source projects, but it's not always obvious. So if you're an open source software, if you're a project owner of an open source software project, sometimes there are ways that you can increase the traction of your open source software project. This is certainly not an area of expertise for us, but these are some of the things that we've seen other PIs and researchers do in the past. The benefit for university startups is because they're coming from academia, they have a pre-existing platform to leverage scientific communities and journals to publicize new projects. Beyond this, very good and easy documentation. It serves as a great entry point for new users. Being very clear with the purpose of the software and how to use it is just a nice way to get people using your software early and easily without too many hurdles. Additionally, core contributors, sometimes it's helpful for project owners to directly reach out and try to recruit core contributors. A lot of the work around this comes around teaching contributors about the project and getting them on board, sometimes being very diligent about answering questions on platforms like Stack Overflow or Gitter or Twitter or Telegram. Another thing in relation to that is accessibility to your community. Many open source software project owners are hyper social media oriented on Twitter and a lot of other mediums. And then finally, blogs are a great way to introduce open source software projects, providing the backstory and the context of why you're building out a certain type of product or project, and then also scaling and growing that community as the community gets bigger. Great, and so there was a question earlier on what were some of the business models around open source software. So here are 5 of some of the more popular ways to go to market with open source software. The example that we discussed previously with Red Hat, also Cloudera uses this model, is completely free and open source software where a private entity is largely providing consulting services or customer support or product quality assurances to their customers. A lot of enterprises want to see this just to have basically a neck to choke in case something goes wrong with the software that they've deployed. Another business model that we've seen as pretty recently popular is software platform and infrastructure as a service. This is essentially hosting open source software and serving it in a subscription model. Usually the software is optimized for the cloud or to run better with better accuracy. This is a really nice way for developers or users to interact with open source software because it takes out a lot of the barriers in installing and running and deploying it yourself. And so Databricks uses this model, so does a company called Heroku. Open Core is another very popular and probably one of the more most popular ways to open source software. This is essentially building proprietary features and modules on top of open source software and then selling those features and modules. And so Elastic recently went public based off this model. There's companies like Neo4j that are also doing this. An older model that Oracle did with MySQL and then also SourceFire with Smart is proprietary. It's basically GPL licensed open source software or copyleft where commercial entities can't embed that open source or can't use that open source software. And so it's essentially a form of proprietary software that has open source code out there but can't be used commercially. And then the last is probably the most recent addition to this model. And it's largely using token economics for open source software like Bitcoin or Ethereum. And there's lots of variety of how you can commercialize via tokens, but blockchain is certainly a great way to commercialize open source software.
So, this slide here, I wanted to dig a little bit deeper into the open core model. And, I want to say you should think of this as one framework out of many different kinds of framework for thinking about open source software startups and in particular, open core model startups and all of the different variables that are involved. This is not a definitive set of rules that are useful for classifying companies. I just think that these are actually, it's nice to define these variables. So let's discuss a broader definition of open core. So if you think about the visualizations here, the visualization is a red proprietary shell around some white open core. So the area in white is how much of it is the open source software, and we call the red part the crust of the core model, right? So each class is defined then by the thickness of this proprietary shell. And so I think this is a useful framework, and I also think it may be useful for tech transfer officers who are thinking about what to protect and what not to protect and what to disclose and not to disclose and so forth. We don't have those answers, but I think that this provides at least a starting point for having the kinds of conversations you want. So let's talk a little bit about some of the parameters in here. So the first variable to consider is a productization. So, an open core startup replaces or extends some open source software project with a commercial product. So for a thin crust open core model, productization could be something as simple as add-ons and plugins that wrap the core software. And they could also be things like a deployment mechanism, like John was just talking about Databricks. If you think about like the skinny crust open core, you could think of that as another way of talking about sort of some of these infrastructure as a service companies like Databricks, for example, which is maintain Spark as a full open source project, but also just provide some little 10% of proprietary crust around it that allows for users to use this in the cloud. They had to make some changes to this. So that's one variable is, how much of an effort or how much proprietary shell are you going to wrap around this project in order to commercialize it? And so that's one interesting thing to think about. Another one here is the delivery model. And, with respect to the delivery model, like these can vary greatly regardless of how the open core is implemented. So this is a tricky one. I actually don't even agree with the ones that are on this table. This also came from Open Source Startup Capital. And so, like, for example, Databricks is not typically on-prem, it's in the cloud. So, but it is another variable, the delivery model. Like, are you going to offer this as a hosted? Are you going to offer it on-prem and hosted? Or is it mostly on-prem, but on some occasions or for some kind of data, it's hosted? So it matters in go-to-market. And so it's something that you want to have a discussion about when you're thinking about commercializing one of these. Some of the other ones here are whether or not the commercial fixes are upstream. So in some cases, and this is true for Databricks, when improvements are made by the core dev team at Databricks to Spark, it gets pushed back upstream to the open source Spark project. But if you go all the way to the thick crust one, like GitHub is another example, or MuleSoft is an example, in that case, when they make changes to the underlying software, and the core of GitHub is Git, they're not pushing that back to the open source community anymore. It's a one-way use case. And so some of the other things are like user control. How much can they configure it and change things? For a thick crust, the users will have minimum control over changes to it. They won't get much access to open source either, source code either, so they can't change much there either. And then the last one is just in terms of code bases, and this is also, I think, relevant to the tech transfer offices. How much of this are you going to open source, and how much of this is going to be kept aside? So there's this idea of dual and single code bases. So for the example of Spark Databricks, there's a single code base for Spark. But in some of the other ones, like MongoDB, for example, there is a fork of proprietary, and Docker has the same thing where they kind of fork the code and they make a separate proprietary dual code base that's under protection. It gets updated on a more regular basis and sold to enterprises. So, again, the examples here aren't necessarily set in stone. I'm just proposing that this is a useful framework to help think about the different variables that are at play, and there are other variables at play also. But I also think it's a nice rubric for TTOs to sit down and use when they're working with faculty who are thinking about commercializing their open source software projects, and kind of gives them a menu to choose from.
So before we hit the slide, Drew Bennett asked an excellent question. And the question was if I could discuss any thoughts I have on Commons Clause and SaaS-based deployment for open source software. And so for those of you that don't know what Commons Clause is, it's actually a relatively new clause in open source licenses. This was popularized by a company called Redis Labs. It essentially adds a provision where that open source software is prohibited to be sold, either as a package or in and of itself. And then additionally, the companies can't offer any support onto it. And so it's actually a great idea for, as an addition to an open source license, you have the benefits of usage and of people being able to use open source software in-house, but not necessarily being able to sell it. So it also has benefits of, in some ways, being proprietary. I would say that whether this is a good strategy or not really depends on the business model that is employed by the company commercializing that piece of software. Sometimes it may make sense to do that. For example, if it's software that most companies are largely bringing in to consume. So for example, if it's like a firewall that they want to bring in and only consume for themselves, it probably makes a lot of sense to have that type of clause in language, in an open source license. But if it's software that is usually embedded into other products to be sold, that's probably a bit more of a challenge because people do need to be able to sell those products, and it may make your open source software largely proprietary at that point, making it not really open source software. The SaaS deployment model is a little bit different. When we talk about Databricks and Heroku, all you're largely doing in a SaaS deployment is providing a pipe in which to consume open source software. And so we actually have a company in our portfolio called Algorithmia that does not really do any open source software development on their own, but they have ported a lot of open source software projects onto their platform and build really easy APIs for other developers to be able to use that open source software. So arguably, they're commercializing open source software by providing the pipes to connect with that open source software. And so it's largely a way in which to make open source software much easier to use, but charging for access to that software where you're not necessarily getting any benefits from having proprietary algorithms, but largely from the infrastructure that you're providing. Great. And so this slide here is largely talk about some of the principles and the economics behind whether and how to decide if an open source project should be commercialized into a startup. It's really hard to give advice around open source startups and which ones to commercialize, largely because it is so case dependent. It's really hard for us to have general rules and general laws about it. It really depends on a case-by-case basis. And so it's helpful to have some of these frameworks in mind, just as I'm sure all of you are considering different open source software startups that are coming to your offices and how you should go about advising them on how to commercialize. And so I'll just go through these one by one. And so the first principle here is fairly straightforward. If you decrease the cost of the good, you should theoretically increase demand for that good. But this only happens when the cost of the good is sufficiently high that when you decrease the price, that it will drive a sufficient increase in the demand. So it wouldn't make sense to drop the cost of an already low product to zero. It may not necessarily increase the demand for that good. So for example, if someone were to try to launch a Linux competitor and they were to offer that for free, it may not be that valuable because Linux is already free. There's a competitor that's already free. It may not increase the demand for it. However, theoretically, if you were somehow able to offer cloud computing for 1/4 the price of AWS, I imagine that would substantially increase demand for cloud compute. The second principle here is decreasing the cost of the good should decrease the demand of its substitutes. And so this is generally just a general philosophy of why open source startups can be market disruptors. An open source software startup targeting a market that has a highly priced, very popular incumbent could theoretically decrease the demand for that incumbent if they offer their product for nearly free. And the third consideration is if you decrease the cost of a good, you increase the demand for its complements. And this is really at the core of the business model for open source software startups. Given that you're giving away a large portion of your software for free, sometimes all of it, how do you generate demand or generate money for that startup? It's largely you're commercializing the complements of that startup. And so, for example, Google did this exceptionally well when they open sourced a project called Kubernetes. Kubernetes is an orchestration platform for containers, which are small virtualized operating systems. that run in the cloud. By open sourcing that orchestration platform, they got more users to host their services or their software architecture on their clouds, therefore eating more of their compute and them generating a lot more revenue from that. And so that's a great example of a company that open sourced a project and earned no direct fees or revenue off that product, but were able to drive a lot more demand for some of its complements and other products by open sourcing a piece of it. Great.
Yeah, so let's talk about, with open source startups about, when to raise capital. And so we kind of identify, sort of three different periods here or inflection points. The first one is sort of when the concept is created. There have been some open source startup funding for blockchain, especially companies and some other kinds of open source projects that receive venture funding early stage in the concept stage. Now, this usually happens either because it's a blockchain startup or because the laboratory and the PI is well known and has a high profile, especially if she's had a startup in the past. This might be something that investors would get in early, but it's risky. A lot of it is risky because it may not materialize. They may have to spend a lot more money than they expect to get to product market fit. And there's also a risk because the startup is taking on, presumably they're taking on a pretty low valuation, and so they're giving up a lot of the company in exchange for this early funding. So, an alternative to this is kind of corporate sponsors, grants, sometimes things with Department of Defense or DARPA, and these can be really helpful non-dilutive funding to kind of get along the product roadmap. The next point here, after you've established a community of developers, is this point that we're calling an equilibrium, where you've identified a problem amongst users. And as I was saying before, you have users that are, you have lots of developers and you have users that are using the software, and they're requesting features that are specific to a particular pain point. They want to they've identified a pain point, and this by how people are using the software. When you get to that point, it's much easier to raise funding from VCs at that point. One of the interesting things here is, typically when you talk to VCs and they ask, tell me about your traction, they usually mean your revenue. They want to know how much ARR you're bringing in. And in this case, you can reach equilibrium with an open source startup. And if the community is very active and there are a lot of people using it, and you can demonstrate that excitement, it could be that is actually a strong indication of traction, even if it's not revenue. And VCs will take this into account, which really gets the startup rewarded with healthy valuations, and there's also a lower risk for the investors and that this will go to market. There are also some open source projects that have kind of been around a while and developed a large community, and occasionally you see this. GitHub, Corelight's another example because Bro was around for a very long time, where some startups are just able to identify a product and they only require the capital to get to scale. There are rare cases, and they are the ideal when you're raising outside capital, because they shouldn't have to raise that much money to get to scale, and they can request much higher valuations and suffer much less dilution. So, all of this is, these are sort of, we're talking kind of broad strokes here. This is some general advice, but it really kind of also depends on what kind of software it is, who's the target customer, and lots of other variables. So you want to kind of sit down and talk to investors and get a sense of, whether or not this is a good time for you to raise money through a VC, or should you really start looking for non-dilutive capital.
Great. We thought it would be helpful to address some of the areas that we're seeing in terms of frontiers of open source, particularly out of universities. I would say over the last 5 years or so, we've seen lots of innovations in open source artificial intelligence. And one of the things that we've seen are that algorithms are rapidly commoditized, and companies are starting lots of open source neural nets and AI techniques. For example, Google open sourced a very popular neural network called TensorFlow that was largely to drive usage of their own cloud. But the impact it had was it largely put a lot of proprietary neural network companies out of business because there was now a pretty solid and pretty usable open source neural network out there. I'd say that a lot of the innovation around open source in this area is that the data is still proprietary. And so to train some of these neural networks and to have more accurate neural networks, data can be leveraged to create open source companies that are pretty interesting. I'd say that we're starting to see some of these companies bubble up, though it's still pretty early. Additionally, there's been a lot of efforts in open source hardware where it's getting really easy to manufacture and prototype hardware. It's largely commoditized at this point, and we see companies offering free or almost free hardware while commercializing the management software platforms for this hardware. And so we have investments in open source software or semiconductor companies, and we've also been seeing open source hardware robotics companies as well. And probably the most notable and hype sector in open source today is the cryptocurrencies, blockchains, and distributed ledger technology companies that are building completely novel methods of commercializing open source software, everything from autonomously managed platforms to currencies. There's a lot of diversity here, and a lot of it is still getting sorted out, but it's certainly an area of lots of development these days. Great. And so one of the things I wanted to hit was kind of crypto and the evolution of open source software. You know, one of the traditional ways that people use or deploy open source software today is that you can essentially view open source programs as libraries where enterprises repackage so that they run them as a service or help those libraries run as a service. And so in that case, there's a certain type of customer that can consume open source projects from commercial companies. There's lots of work to get them running. There's a limited audience. Usually only large companies can consume or benefit from these open source startups. And the incentives for these open source startups is to serve relatively large companies and adopt business models that serve pretty specific customer types. The blockchain enables a lot more universal access for someone considering new types of open source projects because they are distributed in autonomous organizations oftentimes. It's much easier to serve larger populations that previously weren't served by open source software. And this allows for a much more universal audience. Products can be scaled down to atomic units. And the incentive to create these projects goes back to the creators directly. And so, you know, we started seeing some interesting areas within blockchain and crypto. And in some ways, it is really a great and interesting evolution of open source software. Great. So we're almost out of time. Before we wrap up, we'd love to collect everyone's feedback on our webinar. You'll notice a link to a feedback service in your chat box. If you could fill it out, we'd greatly appreciate it. Your responses help us determine any changes to our webinar, plus future topics we'll cover. If you have any additional questions for us, please reach out to us via email on the addresses you see on the next slide. And so thank you, everyone, for your participation in our webinar, and we hope you enjoy the rest of the day.